Okay, hey everyone. Good morning. Oh, good afternoon, actually. So my name is Alex Lay. I'm here to talk to you today about people, platform, and pipelines. So first of all, thank you very much for coming to the session. So my name is Alex. I'm a product manager for Pivotal in London. I work specifically on Cloud Foundry. And so some of you in the audience might already be familiar with Cloud Foundry. Effectively, what we're building at Pivotal is a enterprise distribution of Cloud Foundry. I work specifically on bringing data services to Cloud Foundry. So things like getting MySQL, Redis, RabbitMQ running on the Cloud Foundry platform. Previously, I worked in the engineering team at Pivotal, and I worked on the container technology that runs inside of Cloud Foundry, which we'll talk a bit more about in this talk. But that's pretty cool. You can find me on Twitter, Alex Evade. So you can see we've got our new Pivotal office in Silicon Roundabout in London. So this makes it look a lot nicer than it is. But this is where Pivotal are based in London. So in this talk, we're going to, first of all, explore why people are central to your success. Often people are forgotten when we're looking at technology. We want a framework to solve the problem. But really, most of the problems we have in large organizations today are about people. So next, we're going to talk about platforms. We're going to look at how platforms can lift you up, do a lot of the boring things that you don't like doing for you. And then finally, we're going to tie this together with pipelines. So we're going to understand why pipelines can help deliver success. And then, based on how long this all takes, hopefully we have some time for some demos. So I'm going to show you a bit about Pivotal Cloud Foundry. And then we're going to take a look at creating a pipeline with a new product called Concourse, which some of you might have heard of. It's quite new, came out of Pivotal, but we'll get into that a bit more later. So, why people? Well, really, we're always building software for people. And that's the reason any of us are building applications, services. We want to make someone's life better, and we want to do this through software. And so who's building the software? Again, mostly people are building this. We haven't yet got too much software built by AI, luckily. And who runs this software once it's ready? Again, going back to people. So people are running this software so that we can give it to the users and the developers can ship new stuff. So first of all, what we're going to look at some of the needs and wants of these people. So first of all, okay, this is your user. They've spent lots of money on your service. You've spent lots of money on convincing them to use your service and product. And you want them to have a good time so that they continue to give you money and use your service. So what do they need? Basic user needs are quite simple. A lot of the time, they're after availability. So when they want to use your service or app, it needs to be available and online. And so also, they need it to be reliable. So when they use it, they want it to work correctly. They don't want to have intermittent downtimes and issues with things not working. And so that means kind of well-tested software from our perspective. But we can meet these two basic needs, then we're going to be off to a good start. So next up, what do they want? They want some cool new features. Every user, they quite like using your product, but they want it to be available and reliable, and also they want new stuff. And that's not always easy from an engineering perspective. And if they don't get these new features, perhaps they're going to go to a different product or a different application. So finally, we've got your user. They're happy using your service on the internet, right? They're having a great time. Everybody's happy at this point. But what happens when the service goes offline? Your users become sad. They start having a really bad time. But from an engineering perspective, we say, running servers, designing HA systems, and deploying it, it's pretty hard. It's not an easy problem. So surely your users won't mind a bit of downtime now and then because, they do want those cool features. And this is just something they're going to have to put up with, right? Wrong. Normally, when this happens, the world is on fire. They can't do any of their work. They start tweeting about how terrible your app and service is. They say, we're never going to use it again. And this is kind of what, from the user's perspective, they don't care. They just want to use your service. So next up, sometimes the culprit of the user fire is the developer. And so you're probably a developer, I guess being at DevOps, or you have lots of them in your company. Characteristics of the developers, they hate meetings, so they love coding. And so when a developer is productive in a company, generally everyone's pretty happy. The users are getting new features, things are going well. So what do developers need? So the first thing developers need is some development infrastructure. This sounds pretty basic, but in a lot of places this is quite hard to come by. So they need things that they can run their code on and test it before they put it into production. So next up, they often would like a choice of a language and framework. And of course, a lot of companies will be quite prescriptive and say, sorry, you can only use Java or you can only use Ruby. But actually, when you're solving problems, you want to be able to pick the right tool for that job. You don't want to have to argue for a long time about which framework, which library you can use. And so you also need access to services like databases, queuing systems, email servers. And again, in large enterprise organizations, this can become very hard to come by. And they want all of this today and not in a month. So what does developers want? They want to focus on features. They don't want to have to worry about getting databases, arguing about which frameworks and tools to use, although that can be quite fun. And they really want to ship software. Okay, so that sounds like a great day. If you can do those things, focus on features and ship software, you're probably going to be having quite a good time. So, first thing developers often need to do is find somewhere to run your application. So you need to get a hold of a server. Again, most enterprises, this is still not easy. Even with things like Amazon Web Services and Google Cloud, not many people have permission to provision new things. And so, right, the developer, you've managed to get your hands on a server. Okay, then we're going to put one of our favorite languages on there. We're going to put Java. So probably you would need to SSH onto this server, download, install Java. But just curious, how many in the audience would normally be allowed to SSH onto a server in their infrastructure? Is anyone? A few? Oh, okay, a few of you. Awesome. So next up, you need to get a database. So you need to acquire this database from a DBA team probably. You then need to ask them to set it up, maybe create you a user, create some tables. Because most applications, we need to store data. So great, we've got the database, we've got the server, we've put Java on there. Next up, we need to get our software. Well, before we get our software in there, we need to make sure we have connectivity. So again, this, in some organizations, this can be a challenge. You need to get your application server wired up to some database. You probably have to file some tickets, request access, and some firewalls and permission changes. And then finally, you need to work out how to get your application software onto the server. And so, this often takes months. So our developers have been working really hard, working long hours, and they've been focused on getting servers, getting databases, setting up networks, and deploying their software. And so really, for all the developers thinking is, why is it so hard to ship software? But, we've got a user. They're using our service now on our server. They've got the app deployed, and they're connecting to the database. Everyone's happy, right? It's going well. But in the meantime, your developer has been waiting and waiting because they've been waiting a month to deploy their app. So, their product manager, who's probably a real pain, has been keeping them busy. And so the developer has been kind of sat there at the machine, and they're producing lots of new features. Right? This developer has been very busy. So we've got a ton of features that are ready to go into production. But the problem is these changes will take weeks to go live. You've got a change committee that's waiting for the deploy window. You've raised your tickets with operations, and you still can't get this code to be in production. And so undeployed code is a real risk to your organization. It becomes stale. Everyone forgets what that feature did, why it's even there. The engineer that wrote that code moves on to another team or goes to a different company completely. And also, this code has not been validated by your users. So this feature is sat there without getting any customer feedback. Who knows that in 3 months' time when this goes live, this might not be the feature that any user wants anymore. Okay. So next up, your applications got popular. And your operations team decided to scale it to 2 servers. And they say, okay, we're spinning up this new server, so we're going to put the latest Java on there. Makes sense, right? Because they go, let's have Java 8. So we've got this new server with Java 8, but has your application ever been tested against running on Java 8? Maybe not. So the first thing that's probably going to happen is your app will start going on fire. There'll be some crazy bug. You're going to get phoned up in the middle of the night having to debug this. Nobody likes this because the operations team probably won't give you access to production. And then your app's had some crazy change that's meant the database is on fire. So now you've got to talk to the database team. And finally, something goes wrong with the network, file some more tickets, your customers are unhappy, and we're back to this. The world's on fire, developers getting shouted at by your business, by ops. They aren't trusted to make any more changes because the operations team have said, hey, developers, our customers are unhappy, everything's on fire, so we're going to go through a change freeze, which no one likes. And they probably introduced some kind of crazy control board for making changes. So now you have to go through even more process to get your code into production. So at this point, we've got some very sad users because the service is offline. They're not getting any new features. Developers are mostly spending their time fighting fires or asking for new infrastructure. And nobody gets to build cool new stuff. So that's very sad. So the next person we're going to talk about is the operator. And so these are the people that are working tirelessly in big enterprises to keep things going. They're keeping your software and your application running, and they're responding to all of these fires. And so they often take most of the heat when things go wrong. And so they're having a pretty bad time in many large organizations. But what do they need? They need to keep the software running. So their main job is to keep this thing alive and running in production so that the business can make money. But they want a repeatable process for doing this. They don't want to be having to manually configure everything. And that's a real pain for operations. But if they can get this repeatable process where they don't create snowflakes in their environment, they'll be in a much better place. And finally, they want to automate all of this so that they don't have to sit there and have their 7 screens and manually SSH onto each box and do that again. And so what do they want? They want to sleep. Most operators or anyone that operates production software probably knows that you get these 3 a.m. pager duty calls, and that's no fun. So they also want this snowflake-free infrastructure. So this is where the servers are configured the same, set up the same, the applications deployed are the same, everything is predictable. And they want to have hands-off with production. They don't want people SSHing on, meddling with things, changing things, because that's no fun. And they want to focus on the future. So all this time they spend fighting fires and configuring servers and all this other boring stuff, it means that they can't do things that they actually want to do, like infrastructure capacity planning, new projects. And so these all sound quite reasonable. And so this is how most operations teams feel in large organizations today. Developers having a great time putting out all these new features, and the operators having to shovel off all of this, kind of like fighting the fires and stuff. So remember, this is the most state of infrastructure. And we're back to this. Everyone's kind of like running around, shouting, screaming, nothing good is happening. So now we have unhappy users, we have unhappy developers who can't get any of their code shipped, and we have operators who are tired. But right, this is 2016, Alex. What am I talking about? Things have moved on. Maybe this was the case in 2012, but unfortunately, this isn't the case for all places. But most of the time I hear, don't worry, we've got this figured out. We've got DevOps. This is where everyone in the company got given a credit card, and then they got AWS. And so they could solve a lot of the problems themselves, which has got us a long way forward. So a lot of large companies we work with now, we're seeing them moving towards DevOps. But this is kind of great, but it also brings up some concerns. So let's have a look at what most companies will go and do. So you've acquired your server within minutes from Amazon. You probably then went and installed Docker. And then you think, hey, let me make this a repeatable process and automate this. So you've used your favorite tools like Chef. And so you can use this to repeatedly provision and configure your server, which is great. And then you need to get your code onto the server. So you write some kind of deploy script that will manage this. It might automate Docker or whatever. So now your application is happily living, running in a Docker container, which you probably haven't tested too well, and you don't actually understand how to run Docker in production. But let's just go with this because it's quick and we can deploy things fast. So then we remember there's a user that needs to access this. So we set up an Nginx server. Quite straightforward. But again, we use our favorite tools to make sure that this is repeatable and we can scale them. And then finally, some user can come along and access your application. So this is cool because we've got a few things improved. We can quickly deploy applications. We can use some automation tools, and we get this repeatable process. So the operations side will like this. Development team can ship features quicker. It's a better place than we were at 10 minutes ago. But this is our developer. Now they're looking after infrastructure. So they're setting up servers, they're keeping these running. They're using the AWS or GCP console to go and provision things. They might even have some automation around with Terraform, but they still have to maintain that. They then have to look after these deployment scripts. So this is how to get your code into production. They've probably hand-rolled these scripts. Who knows that if they've tested them that well, there could be bugs in the deployment scripts. They have to iron those out and keep it all running. Next up, they have to worry about security. So security on the cloud is not always simple as you might think. It's very easy to acquire your servers, but setting up the right access rules, firewalls, that's not simple. So now the developer or the DevOps team is worrying about this. They also have to worry about that application health. So is this app still running? Does it need restarting? Has it got enough memory? All of these concerns. Then they have to worry about, how do I upgrade this stuff? We've got all these database servers spun up. We've got these servers running particular versions of Ubuntu. So the developers are also worrying about how to upgrade this platform, probably working with the operations team, but they've still got a lot more responsibility in the DevOps world. And then finally, they might get time to build a feature, because that's kind of what they're paid to do. And this is your boardroom. They're not happy and they're not impressed that you've gone away and built this DIY platform, because they wanted business value delivered today, and they didn't want it in 6 months. But I will admit, from working on Cloud Foundry, building platforms is extremely fun, but it is very time-consuming. We'll get into a bit more about what these kind of platforms do for you. We maybe convince you not to go off and build one of these yourselves. We might have an answer for this. So platforms. We've established that people have these needs and wants. Not all companies are meeting the needs and wants. But what do platforms have to do with this? And can platforms help us create productive, happy people? So this is the first definition of a platform I found on Oxford Dictionary. I don't think that's correct for us. The next definition I found was in the Business Dictionary, which was saying that operating systems, and gave Linux, Mac as examples, that it's a foundation on which all application software runs. Right, that's getting closer. So this is a foundational element to the computing stack where your software can run. So I think that platforms are actually the operating system for the cloud. And so this is where the foundation of software runs on the cloud. I think this is a lot closer to reality, and it gives us a building block when we're moving our applications from self-hosted, legacy-managed data centers into this cloud-native era. So let's have a look at a bit of the history behind platforms. So is anyone familiar with platforms as a service like Cloud Foundry and Heroku? We've got a few people that are familiar with that. Okay, cool. So we remember the days when we had this traditional IT stack. And this is where we managed everything from the top to the bottom. So we're concerned about applications, the data, the middleware layer, what OS it was running. Then we had things like virtualization. Then we also had to go out and buy the servers, buy the storage, configure networking. This is a huge amount of overhead for any organization to manage. So naturally, next along came the IaaS layer. And so this is where you can get access to the underlying servers, storage, networking with a click of the button within 2 or 3 minutes. So this removed that layer of concern from the operations team. They were no longer having to go and maintain servers. They were no longer having to worry about what networking equipment to buy, plugging it all in. They're paying someone else to do this for them. So this made made everyone a bit faster, and you could focus on what really mattered. And so we've still got a lot of things under our concern here. We've got OS, we've got the middleware layer, you've got data, you've got applications. So next up came the PaaS layer. And so I'm going to tell you a bit more about Pivotal Cloud Foundry next. But why is this interesting? It allows us to start moving into this kind of cloud native era. So we have applications and their data. And so this is all we're concerned with. If we can allow a platform to manage things like the operating system, the runtime, services, and then you can rely on the IaaS layer to manage your servers, your storage, and networking, it means that teams can focus on applications and data. And this is where most of your business value is. Because you see in large organizations and any company really, if you can have applications delivering value to customers, that's where you're going to make your money. You're not going to make money by having containers, right? Containers won't make you the money. So this is a concept I'm going to talk about called the value line. This is an idea from Pivotal's VP of Product, James Waters. And it represents where the value falls for your business. And so the first layer we're going to look at is below the value line. And so this is things that you kind of just have to be successful in this cloud native era. So this is things like operating systems, container orchestration, and cloud orchestration. These are solved problems. And if you're going out and solving these kind of problems yourself, well, maybe someone else has done it that's specialized in this and they do it better. So this is where I'd encourage everyone to think about using platforms instead, because it shifts your focus from worrying about this orchestration layer to worrying about things like writing applications. So you can say here we've got an example. You can focus on building microservices with Spring Boot, getting data flow set up. You can then have CI and CD practices. These are all things that can add value to your business, and that means that you can add new features that your competitors don't have. And so I'd encourage everyone to start thinking about: am I doing things at below the value line, or are we working above the value line, creating value for our business? Okay, so we kind of heard a bit about platforms, some of the concepts behind where they came from, and so I'm going to talk to you a bit more about Pivotal Cloud Foundry. So is there any Cloud Foundry users in the room? Got a few. Okay. 200, 300? No. So Pivotal Cloud Foundry is built upon an open source product called Cloud Foundry, which is the leading platform as a service. And so Pivotal are kind of wrapping up this in a commercial offering. And it's full of the latest Cloud Foundry features because Pivotal are the #1 contributor for Cloud Foundry. So we've got a team of something like 200 engineers adding features to Cloud Foundry all the time, and then we put this into the Pivotal Cloud Foundry product. So let's talk about why Cloud Foundry's got some movement behind it. So it's run by a Linux Foundation organization called the Cloud Foundry Foundation. It's got a huge amount of membership, and it's growing all the time. But you can see what's interesting here is you've got members such as IBM, HP, Intel, Pivotal, SAP, but you've also got companies that are integration partners like Accenture, and you're seeing that we've got a real interesting mix here of customers plus vendors plus integrators, which you don't often see in open source foundations. And this is because the customers are really invested in the open source platform. And so they want to be involved in defining what that platform is. So it's quite an open process and open community. So this is the Cloud Foundry kind of haiku. And it's more popular than this tweet might suggest. But the concept behind it is: here's my source code. Run it on the cloud for me. I do not care how. Wouldn't that be nice? You're not having to worry about infrastructure. You're not having to worry about fighting for tickets to provision databases. You can just say, here's my code, run it for me. So how do we achieve this? At a platform level, we've talked about lots of challenges involved in operating these things and running servers yourself. So the first level that we need to look at is the infrastructure automation. So this gives us the power to have a platform that runs on any infrastructure. So you can see here, Cloud Foundry uses a tool called BOSH. It can run on VMware, it can run on OpenStack, Amazon Web Services, Azure, recently announced on Google Cloud Platform. This is another open source project, but it abstracts the cloud API layer. And so this means that we can provision a new Cloud Foundry on top of VMware or any of these stacks. And so you get that cloud portability baked into the product. The next level we're going to look at is this container elastic runtime. So containers, pretty hot topic. Cloud Foundry has its own container scheduling system called Diego. This is built on top of a product called Garden, which is using another product called Runc, which is the core of Docker containers. And so this is interesting because it means that the containers on Cloud Foundry are using the same code to run Docker containers. So we're seeing this industry standardization around the container technology. But it means that we can offer app developers a self-healing HA runtime, so it keeps your application running, so you're not getting those PagerDuty calls in the night. We can do logging and metrics. We can offer zero downtime upgrades so that our users don't have to experience outages when the software is being deployed. And so we can run a variety of applications. So it's super simple with one command to run Spring applications, Ruby, Go, PHP. And also we support bringing Docker images. So you can push your Docker images into Cloud Foundry. And because the underlying technology behind the containers are the same, it means that we can run your containers on the platform as well. So Cloud Foundry has support for a range of managed services. So again, we use BOSH for this because BOSH is great at keeping these servers running. It will do health checks, and you can elastically scale your infrastructure layer with BOSH. So Cloud Foundry services are examples like MySQL, Redis, RabbitMQ, Cassandra. Pretty much anything will be able to run on the PCF platform. You then have this concept of brokered services, where this is adding services to your platform that might exist elsewhere, right? Because many organizations, they've probably spent too much money on some Oracle rack server, and they want to leverage that. So with Cloud Foundry, you can have this concept of brokered services, where you can add external services into your Cloud Foundry marketplace. And why is this cool? It means that developers have this one-stop shop for all of the services your organization has to offer. Okay, so we've seen the platform, but how do you get access as a developer to this? It looks like it's very complicated. There's lots of stuff going on. There's elastic runtimes, there's infrastructure. As a developer, all you have to worry about is one command, CF push. And so this is where you're doing this from the command line. It will upload your application and get it running inside of Cloud Foundry, and then you get all the benefits of that elastic runtime, and you've got a HA application running, ready for users. So we'll see more about this in the demo. So how does Cloud Foundry run your application? This is quite an interesting process. So first of all, we take your app source code. We then apply a build pack. So the build pack's job is to detect what code you've pushed. So for example, we've got a build pack called the Java build pack. This will detect your application as Java. It will download your dependencies, compile it, and then produce a file that can be used to run on the runtime. So once we've applied the build pack process, we'll also add a file system. So this is the base file system, which would be something like Ubuntu. And then we wrap that up inside of a container. So we've now got your source code, the build pack, and the file system in a container. And what we can do is run this build pack process to get your artifact. In Cloud Foundry, we call this a droplet. So this is going to give you two benefits, because we've produced a droplet, and it means next time we need to create a container, we simply create the runtime container, add the file system stack, stream your droplet inside, and then we can start your running application. This means that we have a really, really simple, repeatable process, because say we want 8 containers. We go ahead and create 8 containers on Cloud Foundry. Again, I'll show you later, but there's a simple one command to do this. And then we can simply stream the droplet into each container. And then we have the same identical application running in the same environment, isolated through containers. And so there's no snowflake applications here. All of these are configured exactly the same. So when you're debugging, there's no risk that, how's this container configured? Or which version is this running? Because the platform will make sure that your application containers are identical. So really, we're looking at agile development. And so agile development helps you go fast. You can iterate in your development environments, but it doesn't really help you get to production. This is where agile deployment comes in. And so you can see, like, having a platform like Cloud Foundry means it's super easy to put these apps into production. So if you want to find out more about Cloud Foundry, I'd recommend checking out this quite small book by Duncan Wynn. It's called Cloud Native Platform. It looks like this. We've got some at the Pivotal booth. If you pop by later, you can pick up a copy. There's going to be a full book coming out in the next few months about this from Duncan, but this is a great starter. It will talk to you a bit about platforms, some of the specifics about Cloud Foundry, how it works, how to write your apps, and the best way to get them running on the platform. So definitely come by and pick up a copy later. Okay, getting into the kind of final part before we jump into a demo. So we're going to talk about pipelines. And so platforms have given us this place to run our apps. It's managing the infrastructure. But how does our code get there? We can manually do CF push. That's quite easy. But do operators really want you CF pushing into production? I'm not so sure. So think of pipelines as your route to production. These are kind of things that you would have in your environment that make it super simple for you to get from the development environment all the way through to production. So you'll probably have systems like this using Jenkins, traditional CI. And so it reduces that risk of having code sitting around that's not shipped. And because we want to test these features before we ship them, so we put them through this pipeline, which is a step of activities. So what are some of the characteristics of a pipeline? So pipelines are automated. So there's no manual fiddling. The idea is that you automate everything and put those into repeatable steps. So once you've got the repeatability, you can do the same thing many times with predictable results. And which is great, because when you're doing a production deploy, you don't want something to go wrong. You want the same thing to happen in a repeatable way. Pipelines are also great for visibility. So this is important that you can use these to radiate information. So you'll see in like lots of Pivotal offices around, we have these huge kind of like CI monitors that have pipelines. And pipelines are a great way to radiate this information. And first, also, they're very understandable because you get a visualization of what's happening. So when a new team member joins, they can easily see and comprehend like what's this pipeline trying to achieve, what are the steps, what's involved. So this is a new product that's come out of, it's an open source product actually, sponsored by Pivotal. It's called Concourse. Do we have any Concourse users or anyone heard of it in the room? Okay, awesome. Yeah, so this has been going for maybe about a year and a half now. But it came up with the complex CI requirements for Cloud Foundry. Each team had different environments they need to test it on. They have different configurations they want to use. And teams with some were using GoCD, some were using Jenkins. And that was really, really complicated because of all that kind of UI clicking. And so when you look at the pipeline in Jenkins, rather, it's very confusing to what this is actually doing. It required a lot of explanation, someone on the team to keep that context, whereas Concourse allows you to simplify that into a kind of visual representation using simple constructs. So what does Concourse offer you and why should you be interested? So first of all, you get isolated builds. It's built on Cloud Foundry's container technology. So it means that each time that you do a build, it will run in an isolated container. Afterwards, it will leave that container around for a while so you can go on and see what's happening, which is one of the cool features that I hope to show you a bit later. And so we don't have any more build pollution. So there's no UI configuration in Concourse. This allows you to commit your pipelines with the code, version control them. It stops people going around and fiddling with things they maybe shouldn't be changing. And it then allows you to have simple pipeline building blocks. And so this is one of the really powerful constructs of Concourse, is it's got some simple constructs that allow you to make these very complex deployment pipelines. But it makes anyone that's reading the pipeline, it's pretty easy to understand and follow the various concepts. So let's have a look at a pipeline. This is what you get when you get a Concourse pipeline. You can see that it kind of works left to right. So artifacts will enter on the left, exit on the right. So you can see we've got this PCF demo resource. And so resources in Concourse are things you might care about that might change. For example, if you did a Git commit, you could have a resource that looks at that. So we'll be monitoring these resources, and whenever there's a change, it can be configured to trigger the next stage in the pipeline. So you can see this green box represents a job. This is a job that successfully ran. So this is the responsibility of doing some tests. It can then have an output. So an output of that might be, it might tag or create a release candidate. And so you can see that it's output to this resource as well. And then finally, once we're happy that we've tagged the deployment that we're going to make, we've tested it, and then we can do a zero downtime deploy using Cloud Foundry. And so behind the scenes, there's some complicated stuff going on in these steps. But from a, what do you care about? Is the build passing and where did it fail? This is a great way to radiate information. Cool. So we're going to jump into a quick demo. I'm going to show you a bit about Cloud Foundry. We're going to get an application running. Then we're going to take a look at Concourse and create a simple pipeline. Awesome. Okay, great. So, okay, how's that font size for everyone? Okay, great. So the first thing I'm going to show you is your control center for Pivotal Cloud Foundry. So I'm using Pivotal Web Services, which is a hosted Cloud Foundry. Anyone can sign up for this. You get a 30-day free trial. And this is where you go to monitor your applications. So you can see here that we've got a space called development. And so this is an isolated space within Cloud Foundry where you can do whatever you want and you're not going to impact anyone else. This is great because it means you can push and iterate on your apps and you don't have to worry about breaking some other team's environment or waiting for a long time. So what we're going to do is jump over the command line and we're going to see we've got a really simple application here that we're going to use. You can download this from GitHub. It's called the CF Example Spring App. And you can see we've got a few files here. We've got an app.groovy, an app test. We've got a CI folder, which we're going to use later for Concourse. So you can, if we see the CF API, so we can see we're targeting run.pivotal.io. And so the cool thing with Cloud Foundry is this is a standard client, and you can connect it to whatever Cloud Foundry you like. There's other cloud providers like IBM Bluemix, Any9s, and you can easily run your application on them. But the cool thing is that you have this consistent user experience, and you don't really care where your code is running. You just care that it's running, right? So if we have a look at our first command, cf push. So this is going to take the local application directory and upload it to Cloud Foundry. It's going to assign us a route so that someone from the internet can access this, and it's going to apply the build packs. So hopefully, if the internet connection here is okay, we'll see this happening. So you can see, first of all, that Cloud Foundry is creating you that route. It's creating a binding between the route and your application. It's uploading your files. So now the files are currently in the cloud. They've been stored in Cloud Foundry's blob store. We're then trying to work out which build pack to apply. So you can see here that Cloud Foundry's detected that it was a Java application, and it's chosen the Java build pack. It's created us the staging container that we saw about earlier. It's put the build artifacts in those containers. In the container, run the build pack, and it's created us the droplet. So this means we've got an artifact that represents your code and can be put inside a container, and you can scale this infinitely. Okay, so now Cloud Foundry is going to be talking to the Elastic Runtime component and requesting that it starts running your application. So let's see if this comes online. Oh, great. So that's not working for some reason. Live demos, hey? Right. Let's see. Let's see if we can find out a bit more about why it crashed from the console. Okay, so we can see we've got 2 crashed events. And if we want to find out a bit more, we can do a command like cf logs. And we can look for cf. Let's have a look at the manifest. So we can call this, we can run cfa, and we can see that we've got an application. It started, but it's crashed. So let's have a look at cf logs. So cf logs is a great command for debugging things. So we can see we're tailing live logs from the application. So let's go in here, and we can do something like a restart. So it's going to try and redeploy the application and bring it back online. Okay, so we can see the logs are telling us that we've created a container. Let's see what happens next. Kind of gone off script, but this is quite interesting. Okay, so you can see that we're reporting that it's going to monitor the health of your container. Oh. Okay, something doesn't look happy here. Let's have a look. So let's okay, let's try and repush this application now. This might work. But you can see quickly from pushing the application, you got fast feedback of what went wrong. You can see this through the UI, or you can use the terminal. You can also use debugging tools like cf logs, which is streaming the logs from outside of your container back to the command line. So hopefully we can figure out what's gone wrong. If this doesn't work, we'll get on to the next part of the demo, which is looking at Concourse, which is a bit cooler because it's new. Okay, let's see. This has uploaded the artifacts again. And so while this is doing this, let's take a look and see if we can create ourselves a data service. Okay, so Cloud Foundry has a concept called the marketplace. So what we're going to be requesting is say, Cloud Foundry, show me all the services that could be available to me. So as an application developer, you can choose, say if you know that you need a SQL database, you can see the Cloud Foundry marketplace. So you can see Pivotal Web Services has a ton of services on offer. And so we can simply run, let's make this a bit bigger. Okay, so we do cf create service. And we can say we want to use one called Elephant SQL. There we go. So we can say Elephant SQL, and then we want to grab the turtle. So you can see to the right, we've got descriptions of what these various plans mean. But this is just a basic database, and we're going to call it MyDB. Not having much luck here. Where is it? Yeah, there we go. Cool, thanks. Right, so now we're creating a service, a new database. And so this is going to go off and use the Cloud Foundry marketplace to broker us a service. So we can now see we have that service available to us. Great, so we now have a database service that's available for our application. So let's jump back and see if this application, still failed to start. I'm sure this worked earlier. But what's really cool with Cloud Foundry is you can easily create a binding between your application and this database service. So what this is going to do is effectively allow your application to connect, and it's going to give it the kind of connection details inside of the container. And so your application can read those and connect to your data service really easily. So if we do cf bind service, this is a command. Let's try and make this a bit, give some more space. So this is cf bind service. And so we're going to run cf spring DevOps, and we're going to bind it to MyDB. Great, so now we have the database service bound to your application. I could show you this through if the application started correctly, I was going to show you this through the Pivotal Web Services UI. You can then start to look at what the database contains and do all the normal stuff you would with a database. But this was super simple because it was pretty much 3 commands. So cf push, cf create service, and cf bind service. And then you had your application running in the cloud environment, you had a database created, and then finally you had you had it exposed to your users by a Cloud Foundry route. So that was what I wanted to show you with Cloud Foundry. I'd recommend going to Pivotal Web Services, trying it out yourself with your application. But next up, let's take a look at Concourse. And so what we're going to try and do is get a simple Concourse pipeline that will take our code, it will test it, it will then deploy it to Cloud Foundry. So for this, we're going to use a tool called Fly. So Fly is the way that you interact with your Concourse deployment. And so I'll show you an example of one of our team's pipelines. So this is a really, really complicated Concourse pipeline. So you can see over here, we've got the build status. Oops. So we can see if it's reporting, if it's pending, if it started, it's succeeded. And so you get these visualizations of you can see exactly what's happening in your pipeline. We're not going to make anything this complicated. We're going to do something simpler. So let's first have a look at how you configure a Concourse pipeline. So let's take a look at RCI and pipeline. So you notice that this pipeline is committed alongside the code. And so this means that you can get no credentials. You can get the credentials out of your pipeline definition, and into a secret repository like Vault or LastPass. Okay. So what's interesting here is the concepts we touched on earlier with Concourse. We define what jobs are involved in this pipeline. We can then have multiple jobs, and then we define how they tie together. First of all, we want to define a resource. So you can see this is a Spring sample app. We're getting it from Git, and we're going to go to this source. And so Concourse has inbuilt support for various types of resources, things like publishing to S3. You can also do pushing notifications to Pivotal Tracker. You can push to Cloud Foundry. You can create Semver, so you can create versioned artifacts. And these are all native to Concourse. If you want, there's a really simple extension mechanism to build your own resources. So if you wanted to define a resource to do something else, you can easily do that. So let's take a look at our build plan. So this is all of the steps involved to get your unit tests running. So the first step is we're going to get our application. So this means that we're going to go to Git and download it. And we'll be using this as a base artifact for this step. We're going to set a trigger. So what does a trigger mean? It means that every time someone makes a commit to this repository, that it's going to go off and run an instance of this unit test job. And so this means that simple watching mechanism. So next up, we need to actually run some tests. So we've downloaded the code, and now we're doing this phase. And so we want to do this inside of a container. So we're going to use a Docker image here. We're using a Groovy Docker image, and the input is going to be the sample Spring app. So this ties together the first step, which was the get. So it's going to make those files available inside this container, and then it's going to run a process. So you can see here we're going to run Groovy, and we're just going to run our simple app test file. And so that's quite a straightforward pipeline. It's very easy to read and understand. As your pipeline file grows, you can split these tasks out into separate files. And if you need to reuse those across your pipeline, it makes it quite easy. You just change this reference for a reference called file. So, awesome. Okay, so let's try and set this pipeline on Concourse. Okay, so first of all, we're going to target our Concourse instance. So this is my team in London's Concourse that I'm borrowing. We're going to set the pipeline. We're going to call it DevOps. We're then going to pass a configuration file in, which is our pipeline.yaml. And then we're going to load any credentials in. We haven't put any secrets into the configuration yet, but this is a mechanism where we can load tokens. We'll look at that next. So this is the one command. There's no UI configuration. I've previously authenticated with Concourse, so it knows that I have the ability to create new pipelines. Okay, so we can see here, this is a quick chance for you to review before you push this. So let's say yes. Okay, so now our pipeline should have been created on Concourse. Let's see if I'm more lucky this time. So let's give this a refresh. Okay, so we can now see we have the DevOps pipeline. So great, we have our CF sample Spring app and a unit test box. So if I click play here, so we've effectively unpaused this pipeline. So let's see if we can do something interesting, like getting it to run. So let's make a change to the manifest. And let's say, it's automatically triggered. Great, so it must have picked up a commit I did yesterday on this project. Okay, so you can see that this is now in the pending phase. And so it's gone, and it's going to start to pull down a Docker container. So let's have a look at this in a bit more detail. So you can see here, this is the job box. And so what it's done is it went and got the CF sample app. It's then detected that we requested it run in a container. And so this step pulled the Docker image, it then created the container and ran our tests. And so it ran 2 tests and took 1 second. Awesome. So if we go back to the pipeline view, we can now see we've got a happy green box. And we've put this up on a big monitor on the wall, so all the developers can see that they've now successfully unit tested that code. And then we can trust that Concourse is going to do this in a repeated, automated fashion. Great, so let's take a look at another example pipeline. And this one is going to break, and it's intentional, so let's just hope that it actually breaks and doesn't pass. So the next file we're going to take a look at is pipeline. So this is a bit more complicated. We've added a second job to our pipeline, and this is going to be triggered when the unit tests pass. So this allows us to define dependencies between jobs. So we'll pull down the new code, we'll unit test it. When that's successful, we're going to deploy it to Cloud Foundry. And so you can see that it's also acting on the same like Git resource. It's got the trigger so that when this passes, it will also trigger. And we want to make sure that we only deploy things that pass our unit tests. That's great. So we're using a put task a put type on this next operation. So this is Concourse telling it needs to take the artifact and put it somewhere. In this case, it's putting it to Cloud Foundry. Okay, so what are the parameters? We need the manifest that we've defined. The manifest is just simply telling Cloud Foundry, like, what's the name of this app? How many instances do you want running? And then things like how much memory do you need? So you can commit that alongside your code. You need to tell the resource where to find your application. So you can see here that we're going to deploy this app.groovy. So we now define another resource called deployment. We've tied this together here because we're putting to deployment. And we're going to define which Cloud Foundry API we'd like to talk to, username, password, the organization, and space. So those are Cloud Foundry concepts of how you isolate users within Cloud Foundry. And because we don't need that. We're actually deploying to a real Cloud Foundry. But you can skip certification if you're doing this in development environments. Okay, great. So we've now got a pipeline that should be able to unit test our code, and it should deploy to CF. Great. So let's let's set this pipeline. Okay, so we're now saying we're going to use the deployment pipeline, and we're going to load in the credentials from this creds file. And so what this means is that we've now got no secrets in our manifest file, in our CI file, and we're going to put this straight through. So, okay, great. So we've now updated the configuration of that concourse. So now we see that have this new box, which is deployed to CF. Okay, so we've now got, going from left to right, we've got a box that does getting the latest code. It's going to unit test it. This is going to detect that this unit test is passed, and then it's going to deploy to Cloud Foundry. Okay, so something went wrong. So we can quickly see what's happened, and the team can easily go and start diagnosing this issue. So you can see here, I've configured this to use an older version of the Cloud Foundry CLI. So we're quickly told that this is the error. And so we can go in and diagnose this problem. If we wanted to actually go onto the container, there's a tool called Fly Hijack. So we can use, let's have a look. Okay. So we could go, let's have a look at this deploy to CF. Okay, now we're in the container. So we can just, straight away, we've got from seeing that something went wrong on the screen to jumping into the container, and then we can start having a look around the environment. We could go and have a look at the CF example Spring app. Oops. You can start diagnosing logs and seeing what went wrong. And so you can quickly debug your pipeline and find out what the real issues were through the simple user interface, and then able to SSH into these containers and actually see what's going wrong. And so the container will stay around for 5 minutes afterwards. And so you can do all your debugging, and you can see a list if you run, there's a simple command to see what containers are currently active, and you can see what jobs have been run in there. Doesn't look too nice on that screen. But this is super effective for building pipelines, debugging pipelines, and radiating information to your teams. Okay, so I think we're about out of time for that part of this part of the demo. Sorry I didn't get the Cloud Foundry part working, but I would say recommend checking it out on Pivotal Web Services. Oh. Didn't like changing. Okay. Awesome. So, just a quick recap. We've seen that Cloud Foundry can help you with dev infrastructure because it makes it super simple to get access to development environments. We've seen you can choose your language that runs on the platform. You've got access to a range of services. You get to focus on features because you've got this. You've got the tools you need, and you've got the infrastructure to run it on. And eventually, you can ship software, and you can do that much faster with a platform. And you've seen that the pipeline can automate your way to production. So next up, let's have a look at the operators. So the operators need to keep things running, so they need repeatability, which the platform with BOSH keeps the infrastructure healthy and running. It also keeps the applications running, so they don't have to worry about app crashes. Well, unless you're me and did something wrong. Next, you get repeatability from the platform. It's all automatable, and you can automate this through Concourse pipelines. And this leads to the Snowflake-free infrastructure, because BOSH has created your infrastructure layer in a repeatable way. Cloud Foundry is creating your application containers and runtime in the same way, and so you can guarantee that your application is consistent and you don't get snowflakes across your infrastructure. And finally, they can focus on the future because they don't really want to deal with these calls at 3 a.m., plugging in servers, and so the Cloud Foundry, Pivotal Cloud Foundry platform allows them to focus on their real job. And of course, not forgetting the users. I don't know why he's gone off the screen, but users now get availability from the platform. So Cloud Foundry offers 4 levels of HA. As you saw, you get HA at the infrastructure level, the container runtime level, and this is far more reliable. And it means that because developers can be way more productive, they get cool new features shipped to production often. So if you want to get started with this, there's something strange going on with these slides. You can go to concourse.ci, check out the Hello World example. You can do vagrant init concourse/lite, and this will give you a concourse running on your local machine. It's a very quick way to get started and play with concourse. If you want to get started with Pivotal Cloud Foundry, you can use a tool called PCF Dev. So this is just Google PCF Dev, and you can use a CF-CLI plugin. Again, this brings the whole Cloud Foundry experience into a Vagrant image. You can do things like accessing all of the Cloud Foundry services like RabbitMQ, Redis, MySQL, Spring Cloud services, and yeah, lots of others. So I think I'm about out of time. I'll be happy to take some questions now. I'm going to be heading back to the Pivotal booth this afternoon, so we'll have time to chat then, and you can also pick up a copy of the Cloud Foundry book. So yeah, thanks for your time.